So we start with introduction. Gas chromatography is a widely used for analytical technique for separating, identifying and quantifying volatile and semi-volatile compound in a mixture. In this method, the sample is vaporized and carried in the inert gas such as helium, nitrogen or hydrogen through a column containing a stationary phase. Separation occurs based on difference in the component, volatility and their interaction with the stationary phase. As each component exits the column at a characteristic retention time, it is detected and recorded as a chromatogram. Gas chromatography is extensively applied in environmental analysis, pharmaceutical, petrochemical industry, food quality control and forensic science due to its high sensitivity, accuracy and rapid analysis.
Hi and Assalamualaikum everyone. So today our group will be presenting about experiment 5, which is gas chromatography. So we will begin with objective, which is the first one is to determine the retention times, TR of N-butanol and 2-butanol. Number 2, to identify the components present in a standard mixture based on the TR, which is retention time. Number 3, to identify the components present in an unknown sample. And the last one is to identify the effect on temperature on PR and RS. So the next slide is showing the chemicals and apparatus. The chemicals used in this experiment is propanol, N-butanol and also unknown sample, while the apparatus used in this experiment is shrink, beaker and also dropper. Next, we move to the next slide, which is procedure. We have 9 procedures here. So the first one is the gas chromatograph is powered on and permitted to stabilize. The ejector, detector, oven systems and carrier gas are inspected to confirm they operate correctly following laboratory protocols. Number 2, the GC column is prepared at the specified oven temperature to eliminate any impurities prior to analysis. Number 3, the sample is created by dissolving it in an appropriate solvent and filtering if necessary to eliminating particulates. A standard solution is additionally created for calibration objective. Next, a recognized standard is introduced into the GC system to adjust the instrument and establish the retention time of the analysis. Number 5, a small amount of the prepared sample is inserted into the ejector pot with a micro shrink in a controlled manner. Number 6, the sample is turned into vapor and transported through the column by the carrier gas. Separation takes place due to the interaction between the components of the analysis and the column stationary phase. Next, the individual components are identified by a suitable detector generating a chromatogram, followed by the resulting chromatogram is examined by assessing retention times and peak areas against those of the standards. And the last procedure was, following analysis, the device is permitted to cool off and power down in accordance with laboratory safety protocols.
Moving on to this slide that shows the retention time of a standard mixture at 140 degrees Celsius that shows 2 peaks. First is 2.244 and second is 1.956 minutes. Moving on to this slide shows the retention time of a standard mixture at 100 degrees Celsius, which consists of 2 peaks. First is 3.281 and the second one is 2.271 minutes. Next, this slide shows the retention time of standard mixture at 70 degrees Celsius, which shows 2 highest peaks produced, which is at 2.675 and 5.829 minutes. This shows the retention time of 2-propanol at 70 degrees Celsius, which are at 2.709 minutes. This shows the retention time of N-butanol at 70 degrees Celsius at the retention time of 5.974 minutes. Lastly, this shows an unknown sample at 70 degrees Celsius with a retention time of 5.971 minutes. Now I am going to explain about the results. For compound standard mixture at 70 degrees Celsius, the retention time is 2.675 and 5.829 minutes. Next is for 2-propanol compounds at 70 degrees Celsius, the retention time is 2.709 minutes. Third is compound N-butanol at 70 degrees Celsius, the retention time is 5.974 minutes. And fourth, For the unknown sample compound at 70 degrees Celsius, the retention time is 5.971 minutes. Next, for standard mixture compound at 100 degrees Celsius, the retention time is 3.281 and 2.271 minutes. And lastly, for the standard mixture at 140 degrees Celsius, the retention time is 2.244 and 1.956 minutes. Now, moving on to the discussion part. To determine which peak in the unknown chromatogram correspond to each compound in the standard mixture is by comparing the retention times with the standard mixture and individual pure compound analyzed under identical gas chromatographic conditions, particularly at the same column temperature. The standard mixture was primarily compared at 70 degrees Celsius, which was chosen as a reference temperature to provide a consistent and controlled conditions. This ensured an accurate comparison between unknown samples and the standards. At 70 degrees Celsius, the standard mixture produced a characteristic retention time for its components. Pure compound analyzers further confirm this value. First, 2-propanol yielded at approximately 2.709 minutes and 3.622 minutes. Second is N-butanol produced peaks at approximately 2.652 minutes, 2.925 minutes, and 5.974 minutes. The unknown sample analyzed at 70 degrees Celsius showed peak at 2.654 minutes, 2.926 minutes, 5.060 minutes, and 5.971 minutes. The value of unknown peak, like I just mentioned before, are closely matched to the retention time of N-butanol, confirming its presence in the unknown sample. Thus, peak was identified through retention time matching, comparison with pure standard, and consistency across multiple temperature runs, which provide reliable compound identification in gas chromatography analysis. Furthermore, reducing the column temperature increases the interaction between analytes and the stationary phase, resulting in a longer retention time and improved peak resolution due to greater separation between peaks. However, very low temperature can lead to longer analysis time and broader peak for less volatile compounds. In contrast, increasing the column temperature reduces analyte stationary phase interactions, causing compounds to elute faster with shorter retention times, while this speed up the analysis peaks may elute closer together, leading to reduced peak resolution and possible peak overlap.
Our last slide is conclusion. In conclusion, gas chromatography was used to determine the retention time of 2-propanol and N-butanol. At the 70 degrees Celsius, 2-propanol had a shorter retention time, which is 2.709 minutes, compared to N-butanol is 5.974 minutes, due to its lower boiling point and weaker interaction with the stationary phase. Next is the standard mixture show two peaks corresponding to 2-propanol and N-butanol. The unknown sample produced a retention time of approximately 5.971 minutes, which closely matched that of N-butanol, indicating that the unknown compound was N-butanol. Lastly, the effect of temperature on retention time and resolution was observed by increasing the column temperature. Higher temperature result in shorter retention time but reduced solution between peaks, while lower temperature provide better separation with longer analysis time.